Hi students, எப்படி இருக்கு? So today we have one of the best topics. So many students were eagerly waiting for organic chemistry. So I thought of initially starting with naming, but thereafter I thought, okay, naming most of the students might be knowing it. So let us start with the reaction mechanism. So all of you are ready, okay? So here we have the new Neet reduced syllabus is out there, and we know from the last 2 years we are having question patterns with assertion and reasoning. So many students requested me, sir, we need more practice of the questions of that type. So we are starting with assertion and reason initially for reaction mechanism. We have a number of questions to do purely based on NCERT and something little extension of NCERT, because last year you can see some questions were extensions of NCERT. So we don't want to skip that. Okay. So I'm sure all of you are watching this. So please take a note and also note down the questions and write it down. And maybe if you are okay, we will at the end of the day, we will put this PDF in our as a link. You can download it. Okay. So I am Riaz Ahmed. Okay. Part of Brainiacs Classes. We are located at Coimbatore. This is one of the best NEET bar JE coaching center available in Tamil Nadu. Okay, so if you look at our past year records, we have delivered more than 100 plus doctors in our past 4 years from a single classroom. That is very important, and from average students. So most of the students who came to us were very average students, but they have one thing in common, that they were passionate to become doctors. So I always recommend students, it's not the IQ or any other thing matters, it is the passion. So if you have a passion to become doctor and if you have the right guidance, you can easily become doctors, because then only you will do it naturally. Otherwise, sometimes everybody need to push you from around. That should not happen actually. If this job is your passion, then you will do it continuously. You don't need any sort of push or pull. Okay. Yeah. So that's all about us. Now let's start with the concept of assertion and reasoning. So let me give you an introduction on assertion and reasoning. Very simple. So in an assertion reason model type of question, there will be two statements. One is an assertion and the second one is a reason. You can see here. Okay. I am giving you an example. You can see here assertion, one statement would be there. Okay. Then there would be reason, one statement would be there. Then what we need to do here, please understand here how you attend assertion and reason. First thing is, you have 4 options. Similar to other questions, we have 4 options for assertion and reasoning. So option A is what actually? When you will mark as option A, whenever the assertion and reason both are true means individual statements are true. Then what is the next condition? And the reason, it should be the correct explanation of the assertion. Assertion may be speaking about something and the reason will be the proper exact answer for that assertion. In that case, we say our answer is option A. Clear? Okay, so usually the reason would be because of why it is like that. Maybe why assertion is like that. That will be the answer as the reason. In that case, we say assertion and reason are individually true statements, and the reason mentioned here is an exact explanation for the assertion. Okay, so you should be very clear about the and part, because you need to understand why the reason is the reason correct or not. All these things you need to take care. Okay, there actually the examiners can check your deep knowledge, whether the students know exactly why it is like this, or if you mention a different reason, are they able to identify it. All these things they will check. Okay, that's why this is a time consuming process as well. So surely students, you need to practice a lot in order to crack this type of questions very fast. That is within 1 minute. Okay. Then when you will choose option B as the answer, very simple, sir. When both the assertion and reason are true, please listen here also, both the assertion and reason are true. That means assertion is a correct statement and reason mentioned is also a correct statement, but the reason is not the correct explanation of the assertion. That means the reason is a correct statement, but it is not the correct explanation for this particular assertion. Okay, then we have, when you will mark it as option C, sir, option C. Option C means assertion is true, but the reason mentioned there is a false statement. We are not checking it whether that reason is an explanation and all not. Here the reason itself is a false statement. And the last one, that is the option D, where both assertion statement and reason statement both are false statement. Understood? So please be careful of what is the meaning of these four statements. Okay, now we will start with one by one. We will do the questions. Okay, now I hope all of you could see our first question. So there one assertion is mentioned. What is the assertion, sir? All of you go through it. The assertion mentioned here is the tertiary carbonium ions are generally formed more easily than primary carbonium ions. So they are speaking about the reaction intermediate carbocation, and they are telling that tertiary carbocations are generally formed more easily than a primary carbocation. Okay, now we need to understand why it is like that. Those explanations I will come to it. Next, what is the reason mentioned? Why they are telling, why tertiary carbocations are generally formed more easily? They are telling hyperconjugative as well as inductive effect of additional alkyl groups stabilize a tertiary carbonium ion. So that they are telling that in a tertiary carbocation there is an effect called hyperconjugation and there is another effect called inductive effect, and these two effects are more in a tertiary carbocation. Why it is more? They are telling because more alkyl groups are present in a tertiary carbocation. So that's why they are telling these tertiary carbocations are generally formed more easily. Okay, now we need to understand what is a carbocation, what is a tertiary carbocation. These things I will give you an idea, then you will get the exact meaning. What does it mean? Okay, whether you will understand it as correct or not. Okay, so let's understand what is a carbocation first. Tell me, sir, what is fundamentally a carbocation? What is a carbocation? So you can see that carbocation, from that meaning itself you can say you have carbon with the cation. That means carbon carrying, I can easily say it's nothing but carbon with the positive charge. What is it? It is nothing but carbon with a positive charge. Now fundamentally if you are speaking, the carbocations are classified generally into three. Okay, so first one is called a primary carbocation, 1 degree carbocation. Okay, and the second one is called a 2 degree carbocation, and the third one is called a tertiary carbocation. Okay, you might have learned all these things in the theory, I am sure, but we need this as a revision. That's why I am explaining these things. Tertiary carbocation. Now what do you mean by a primary carbocation, sir? Very simple. Whenever your carbocation, that is carbon with a positive charge, is connected to only one other carbon atom, let me say it is connected to CH3. Okay, it is connected to only this one, only one other carbon atom, then we can say this type of carbocation is called a 1 degree carbocation. Because why I am telling that? Because this carbon is connected to only one other carbon atom. Correct? Now what is a secondary carbocation, sir? Very simple. Try to understand. Now you can itself tell me. You have a carbon atom and this is connected to two other carbon atoms. Let me say here one CH3 is present. Okay, and here another CH3 is present. Okay, you have here CH with here positive charge is present. So this type of carbocation is called, what it is that? Tell me, sir. This is called a 2 degree carbocation. Why we call it as 2 degree? Because this is connected to this carbon atom and this is also connected to this carbon atom, two other carbon atoms. So that's why it is called a secondary carbocation. Okay, now let's understand what is a tertiary carbocation, sir. Very simple. So when you see the tertiary carbocation, you have a carbon atom and that is connected to, tell me, sir, now you can tell me easily, it is connected to three other carbon atoms. Okay, so let me say here one CH3 is present. Okay, here one CH3 is present. Okay, and here one CH3 is present. Okay, and here you have the positive charge, that is the carbon carrying positive charge. So this type of carbocation is called a tertiary carbocation. I hope you understood the carbocation, what it is. Now the next thing you need to understand here is, what are the factors that influence the stability of carbocation? So I can say there are three factors mainly. Okay, so factors influencing stability. Okay, So we can understand factors affecting stability of carbocation. Factors affecting stability, okay, of carbocation. Factors affecting stability of carbocation. Tell me, sir, what are the various factors? You might already all of you might have learned it. Let's just listing it out. First one, the very important thing, that is the resonance. So if there is a resonance in a particular carbocation, then that particular carbocation would be more stable. Then we have an effect that is called hyperconjugation. Hyperconjugation. Okay. Then we have something that is called inductive effect. Inductive effect. Okay. Okay, now please understand, sometimes all these three effects might not be present. Individually, they would be present actually. Okay, now when I am comparing here the primary and tertiary carbocation, I can see there is no resonance is present. Resonance means there should be conjugation. Conjugation means alternate of single bond and double bond, or alternate of single bond with a positive charge or negative charge or lone pair. But there is no conjugation present here in this one or this one. And hyperconjugation simply means whenever you have an electron deficient carbon is there. Electron deficient carbon is there. So you can see positive charge means there is what is present. So here what is present, sir? Positive charge means, 1 minute. Yeah, there is some issues, don't worry. We'll go to it. Okay. Okay, so there are some glitches, don't worry about that, we will come to it. Okay, so here listen students. So very simple, hyperconjugation means very simple, we will go that in detail. Whenever you have an electron deficient carbon is present, okay, whenever you have an electron deficient carbon is present, and listen, and nearby you have a CH bond is present. Nearby if you have a CH bond is present, okay, then what will happen, sir? What will happen? What is the phenomenon observed? We observed that in chemistry most of the things are observations, and based on that we are explaining. We understood that this bond will disappear. This bond will disappear and this bond will come here to, or this bond means this pair of electrons will move to here to remove this deficiency, and this phenomenon is called hyperconjugation. So please understand that whenever you have a carbocation with a positive charge and nearby CH bonds are there, that will disappear and come here to remove the positive charge. The phenomenon is called hyperconjugation. Now here if you see in a primary carbocation there are 3 CH bonds are there. CH3 means 3 CH bonds are there. So 3 alpha hydrogen is ready to make this compound stable. Now in a tertiary carbocation you can see there are 3. This is also nearby carbon atom with 3 hydrogen. This is also nearby carbon atom with 3 hydrogen. So totally 9 alpha hydrogens are ready to help you, and this is more stable because 9 people are ready to serve you. You can say easily like that. So I can easily say hyperconjugation is making a tertiary carbocation more stable than a 1 degree carbocation. Okay, next is the inductive effect. Inductive effect, we can say it is classified into, it's a feeble effect. It is classified into plus I effect and minus I effect. So what happens in a plus I effect? Plus I effect means there are certain groups which will repel the electrons. I can say electron repelling will occur. What will occur, sir? Electron repelling. So what will happen? Here I can say, you can see here 3 CH3 groups are present. 3 CH3 groups are present. Okay, 3 CH3 groups are present, and we know that the CH3 groups have what effect? Plus I effect. And there are groups which have minus I effect. Minus I effect means what? Electron would be attracted towards you. electron would be attracted towards you. Now here CH3 group have plus I effect. So what these guys will do? These guys will push the electron towards here. Three CH3 groups are helping it to pushing the electron towards here. So what will happen? The positive charge will decrease. So charge decreases. Charge and stability is inversely proportional. Charge and stability. So we can say that charge here decreases, then stability. What will happen to the stability, sir? Stability increases. Okay, so here 3 CH3 groups are helping you, but here only 1 CH3 group is helping you. So I can clearly say that hyperconjugation and inductive effect is helping you to make the tertiary carbocation more stable. Now you can ask me, sir, they are not telling about stability or anything. They are speaking about bond breaking. They are speaking about what they are telling. Tertiary carbonium ions are generally formed more easily. So they are telling its formation. So very simple, sir. I will explain this with an example. You can see here. Okay, 1 minute. Yeah, you can see here I have taken a tertiary alkyl halide. Okay, why tertiary alkyl halide? Because this is connected to 3 other carbon atoms. So tertiary alkyl halide. Now I can say that this alkyl halide in this particular compound, this bond will break very easily. Why? 2 reasons are there. This is a polar bond. This is a polar bond. Why it is a polar covalent bond? This is a polar covalent bond. Why? Because chlorine is electronegative and carbon is electropositive. So this electron that is present here will move towards chlorine and the bond strength would be like this. Like this. So I can easily say this will undergo breakage, and moreover chlorine is a bigger size atom. Okay. So and moreover I can easily say once the chlorine is removed from this one, what it is forming, what this compound remaining structure looks like, it is a tertiary carbocation. If this tertiary carbocation is unstable, what will happen? It will again attract back the chlorine very fast. But this compound is stable. Why it is stable? Because we learned that it has 9 alpha hydrogen. Through hyperconjugation it is stable, and also it has 3 CH3 groups with the plus I effect. All these will donate electrons to here and makes the compound stable, and this is the reason we say. Okay, so I can clearly mention this is stabilized by hyperconjugation, 9 alpha hydrogen and plus I effect of methyl group. Okay, so I can easily say here I have shown you what is this no bond resonance. So no bond resonance is the another name. No bond resonance is the another name for what? Hyperconjugation. No bond resonance is the another name for hyperconjugation. There is another name still exists, that is Baker and Nathan effect. We call hyperconjugation also as Baker and Nathan effect. Okay, so I have shown you how hyperconjugation happening. Okay, you can see this as our structure, and here any of the alpha hydrogen will remove its bond and form a double bond here. So that is shown here. You can see. Okay, 1 minute. Let me. Okay, so here you can see, to highlight it, you can see here there was a bond was present, that was removed, and here it is forming that bond and positive charge disappears. So I can say this is one structure, one resonating structure or no bond resonating structure of hyperconjugation. In the other one you can see even this guy can go, or even this guy can go, even this one, even this hydrogen, or even this hydrogen, or even this, or even this, or even this. 9 hydrogen have equal chance to form the double bond here. So here I have shown you the second hydrogen forming double bond here. So like that I can draw 9 structures. So I can say 9 people are ready to stabilize the compound. Now here from this I can understand that here the assertion is a correct statement, and the reason exactly mentioned why the assertion is true, or it is the correct explanation for the assertion. So what would be the answer, sir? So both assertion is a correct statement, reason is also a correct statement, and reason is the exact explanation for the assertion. So I can say the answer is option A would be my correct answer. I hope it is clear for you. Okay, now let's try to do the next question. So here also we have the next question, assertion and reason type. You have the assertion mentioned here. Okay, what is the assertion shown here, sir? Listen. Yeah. So I hope you could see the assertion. So the assertion mentioned here is phenol. You can see, you can read the statement. Phenol is a stronger acid than alcohols. So here they have mentioned alcohols. So I am assuming that it is not aromatic alcohol, because aromatic alcohol is nothing but our phenol. Correct. Whenever, what is aromatic alcohol means? Whenever the OH group, let me explain you first. Whenever, I will explain here, whenever the OH group is directly connected to an aromatic ring like a benzene, we can say such a type of compound is called aromatic alcohol, and we name this as fundamentally phenol. Okay. So here they are telling the phenol is a stronger acid compared to other alcohol. Other alcohols are what? Aliphatic alcohols. Aliphatic alcohols means you have alkyl groups connected to, let me say, CH3, CH2OH, or generally we can say ROH. Okay, alkyl group connected to OH group. So such a type of alcohols are called aliphatic alcohols. Now they are telling phenol is stronger acid than alcohol. First statement. Next thing is phenol is stabilized by resonance, whereas alcohols are not. That is what they are telling as a reason. Now we need to analyze these two statements. Okay. First one is phenol is a stronger acid than alcohol. Now an important question will come to your mind. Sir, how will you check whether a compound or whether anything is a very good acid or not? I will tell you one simple shortcut for doing it. Okay, so the most important thing you need to do to check for acidity. Okay, so I will give the heading as check for acidity. This is a very important, we will use it many a times. Check for acidic nature. Okay, checking for acidic nature. How we can do it? Okay, first thing is whatever compound is given. Okay, whatever compound is given, you need to check. What you need to do, remove from that the H plus and check the remaining structure is stable. Okay, what is the condition we need to do? How to check it? Whatever structure is given, remove H plus from the given structure. Remove H plus from the given structure. This is the first step. Remove H plus from the given structure. What is the next step, sir? Very simple. Next step is check if the remaining structure, what is the remaining structure? The structure formed after removing the H plus. Check if the remaining structure is stable. How will you check the stability? Okay, so we add that as a point. Note the stability of a structure, is checked through three phenomenons. What are the three phenomenons, sir? Just now we have learned. First is check whether resonance is present in that compound. Then that remaining structure is highly stable. What is the next one you need to check? After, if resonance is not present, hyperconjugation is present. Okay, if these two are not there, then check whether inductive effect is present. Okay, so it is like R, first you need to give priority, then you need to give hyperconjugation, then only you should consider inductive effect. Very, very important. So if any of these three effect is present, and suppose some students say, sir, in one structure resonance is present, and when I am comparing with another structure hyperconjugation is present. So what to do, sir? Very simple, give priority to resonance. First resonance, then hyperconjugation, then inductive. Okay. Now let's try to understand. With some examples. Okay. Just a minute. Yeah. Okay. So let's try to understand with examples, then you will get a clear clarity of what I am meaning. Okay. Now suppose I am taking a compound like this. Let's take a compound like this. Okay. 1 minute. 1 minute. I am taking a compound like this. CH2 double bond CH double bond CH, then I have CH2OH. It's a bigger compound actually. Don't think about what is that compound, nothing. Just as an example. Now you need to check whether this compound is highly acidic or not. First thing is, whenever they are checking the acidic stuff, you need to remove the hydrogen from an electronegative element, not from the carbon usually. If an electronegative element is not present, then only you should remove it from carbon or other electropositive element. So here electronegative element oxygen is present, so we will remove the hydrogen from here. So what will happen, sir? First step we are doing, remove the H plus. When H plus is removed from here, what will happen? H plus is removed means the two electrons in this bond will move to here. So H plus I need to remove, first step. So I am removing the H plus. So what you are getting? You will get a negative charge here. Why? Because it is H plus. H plus is removed. Okay, H plus is removed. Now next thing, you need to check whether this particular compound is stable or not. Okay, so for stability we need to check whether this minus charge, stability means how will you check whether the remaining structure is stable? We want to say the charge that is present here is the minus charge. Okay, so here 1 minute, I have some glitch. Okay, here the charge that is present here is the minus charge. The charge should decrease. How will you check stability? The charge should decrease. If charge is decreasing, then stability, what will happen to the stability, sir? Stability would increase. Charge and stability are inversely proportional. Now we need to check whether the remaining structure that is present here would decrease the charge that is present on oxygen. That is the most important thing. Now we know that here double bonds, we need to see here how it is possible. So we can see here these things, this particular structure will attract, this particular structure have minus I effect. There is no resonance present here, double bond, single bond, double bond, then both are single bond. So there is no resonance in this part. Okay, there is no resonance in this part, but here you can see conjugations are present, but that is not impacting this one. Okay, so but here this structure has what effect? Minus I effect, because of the double bond present. So minus I effect means it will attract the electrons in this direction, like this. So electrons will move in this direction. So electrons will shift in this direction. So what will happen, sir? Electrons are shifting in this direction means the charge here decreases and stability would increase. So this is how we are analyzing it. Okay, this is one simple example. Now let us try to understand with a phenol case itself. Now in our case, you have the phenol is given here. So in phenol, I can see hydrogen is attached to electronegative element oxygen. So how I will check its acidity? I will remove the hydrogen as H plus. I will remove this hydrogen as H plus. So H plus is removed and the remaining structure, what is mentioned here, is called my phenoxide ion. This is called phenoxide ion. Now if I am drawing its detailed structure, phenoxide ion would look like this. Now you can see here negative charge, then you have single bond, then you have double bond, then you have single bond, then you have double bond, then you have single bond, then you have double bond. Like that it is having conjugation, that is alternatively with a single bond it is varying. So between every single bond you can see either a double bond or a negative charge is present. So this alternating phenomenon is called conjugation. Now because of this conjugation it can form what? Resonating structures. Resonating structures, or this I can say this negative charge will undergo what? Delocalization. Delocalization means what? Moving away from this particular position. Then some students will ask me, sir, delocalization occurs, but why the delocalization is giving stability? Very simple. While doing the delocalization, the charge present in the oxygen, the charge in oxygen is decreasing. Why? Because this charge is dispersing, or it is undergoing delocalization. That is the reason why charge decreases, we say stability increases. Okay. So even to our case also, you can think, humans also, think about it. If you eat lot of food, you have lot of charge, then you are not what you can say, you are unstable. Why you are unstable? You will react very fast. If somebody comes to you, you can say, if you hit you, you will hit back, because you are reacting. But if the charge is very less, you are fasting. Okay, let's say you are fasting, charge is very less. If somebody hits also, we say, sir, we are tired, go back. We are stable. Stable means less movement, we can say no movement, almost staying idle. That is called stability. So applicable everywhere. Okay. So you can see here, the negative charge is delocalizing to here, moving to here. When negative charge comes here, you can see this particular carbon atom will have 5 valency. So this will disperse to this particular carbon as a negative charge here. So that is how the next resonating structure comes. So this is like a effect after effect. This is the effect that is moving here is the effect, and the after effect is this is coming to here. So effect and after effect together constitute one resonating structure. I can say like that. Now in the next step, will it stops here? No. Here also you can see negative charge, single bond, double bond. Here also you have conjugation. So what will happen again? Negative charge will move to here, which is the effect. Then because of that, when negative charge comes here, here you have hydrogen also. So this particular carbon atom will have 5 valency. So what is the after effect? This will move to here as negative charge. So I can say here, this is moving to here as a negative charge, you can see here, and this is coming here as a double bond. You can see here, this is as a double bond. Now again this would continue. Why? Because you can see negative charge, single bond and double bond. Here also alternation is there. So this will come to here and this will move to here as a negative charge. You will get the next resonating structure. And again you can see negative charge, single bond, double bond. So what will happen? Negative charge will come here, then this will come here as a negative charge. So again you can draw like this, it will come here, sir, then this will move as a negative charge. But again that is a repeated structure of this one. So I can say there are 5 different resonating structures, and this is also called canonical structures. Canonical structures. And these structures are giving stability. How it is giving stability? By dispersing the negative charge to different positions. Okay. So I can say phenol, it is not phenol, it is a phenoxide ion that is stabilized by resonance. Okay, we can say phenol is acidic. Why? Because the phenoxide ion is stabilized by resonance. It is not the phenol stabilized by resonance, phenoxide ion is stabilized by resonance. That is the reason, correct? And phenol is also having resonance. If you see phenol alone, you can see lone pair is present. So lone pair, single bond, double bond, it can enter into resonance. But that is not the reason actually. Here why phenol is acidic? Because after removing the H+, the remaining structure is a phenoxide ion, and this is stabilized by resonance. So I can say phenol is acidic because the remaining structure phenoxide ion is stabilized by resonance. Understood? Okay. Now let's understand aliphatic alcohol. I am taking an aliphatic alcohol, ROH. So this R can be any alkyl part. So here I am taking CH3CH2OH, ethyl part. Now similarly, I want to check whether this is acidic or not. What I should do? The hydrogen connected to oxygen is removed as H+, and the remaining structure is called my ethoxide ion. I need to check whether this is stable or not, ethoxide ion. So how you will check it, sir? I have expanded the structure of that. I have expanded its structure. Then I am checking whether any effect is present here. There is no resonance, I can see. There is no alternate double bond or negative charge. Nothing is present here. So there is no conjugation here. But I can see this ethyl group that is connected to this O- has what charge? Plus psi effect. And I told you that plus psi effect means electron would be repelled from that group. electron would be repelled from that group. That means this electrons that is present here will repel. Repelling means moving away. So this will also push the electron in this direction, and this will push the electron in this direction. So what will happen? The charge, the negative charge present here increase. I can say charge increases. So charge increases means stability decreases. Understood? So I can say clearly here phenol is more acidic. Phenol is more acidic, stronger acid compared to alcohol. Why? Because phenol can easily give the H plus, and the remaining structure of the phenol, that is phenoxide ion, is stabilized by resonance. Here, why this question is very important, sir? Here assertion is a true statement. Assertion is true. And you see the reason. Phenol is stabilized by resonance, whereas alcohols are not. Correct. Phenol is stabilized by resonance. We have seen that phenol itself is stabilized by resonance. Why? Because phenol have lone pair, and this lone pair can enter into resonance. But is the reason correct explanation of the assertion? No. Why? Because phenol is stabilized by resonance is not making the phenol as a stronger acid. Why? Because the phenoxide ion should be stabilized by resonance. Here, instead of phenol, they should mention it as phenoxide ion. Then only I can say this reason is a correct explanation of assertion. I can say assertion is a true statement, correct? Reason is also a true statement, correct? Because phenol is also stabilized by resonance. But reason is not the correct explanation for the assertion. Why? Because if reason should be the correct explanation, means here instead of phenol, what they should mention? Phenoxide ion. Phenoxide ion is stabilized by resonance. Because of that, phenol is a stronger acid than alcohol. So this is very, very important. Most of the students will forget this. Okay, even though they understand the concepts. So what should be the proper answer here? So here the answer should be option B should be the correct answer. Why? Because assertion is a true statement and reason is also a true statement, but reason is not the correct explanation for the assertion. Hope you understood. Okay. So students, understanding this type of questions is very, very important for the NEET exam. Otherwise, you will lose marks. You know that if you lose one single question itself, 4 marks would be lost. Your rank will go down. So please understand, we have Brainiacs classes. So you can join our Brainiacs classes YouTube channel and you can watch our previous revision lectures. You can go to our playlist and watch BIRV. There is a playlist called BIRV, Brainiacs Intermediate Revision Series, where you will get all important questions from all the chapters. And if you are willing to take an offline coaching, you can directly contact Brainiacs Classes. It's one of the best NEET coaching centers available in Coimbatore. Okay, so let's do with the next question. That is a very important question here out for you and an expected question as well. Okay, so in this question you are given again an assertion and reason. Okay, an assertion is mentioned here. 2 structures are given. Okay, so they have given you 2 structures. This is the structure number 1 and this is the structure number 2. Okay, you have structure number 1 and structure number 2, and they are telling 1 and 2 are not acceptable canonical structures, or they are telling that even though these 2 structures, they are given these 2 structures, but this structure and these 2 structures are not related, or they are not resonating structures. They are not RS, resonating structures. We need to see why it is like that. And they are mentioned a reason like carbonium ions are less stable than ammonium ions. They are telling carbonium ions are less stable than ammonium ions. We need to see this statement and we need to check whether this reason is a correct explanation for this one or not. Okay, let's try to understand this one. So let me explain this with this particular example. So what is that first structure is called, sir? Okay, I will tell that. Now, the first structure is formed from a compound that is called aniline. You might have learned aniline in your chapter amines. So, how aniline is formed? Whenever you have benzene ring and directly amino group is connected to that, we call such a structure as aniline. Now, how the structure 1 is formed here? How the structure 1 that is shown here is formed? Let's try to understand. So aniline, if you see, nitrogen is present. Whenever nitrogen is present in a compound, it has 1 lone pair. So you can see 1 lone pair electrons are present here. So aniline here undergoes protonation. So I am telling how the structure 1 is formed here. Okay, protonation means adding H plus. Okay, so or simply I can say you keep aniline in a acidic medium. What medium? Acidic medium means it has lot of H plus present there. So what this H plus will do? H plus will have an attraction towards lone pair. Lone pair is negative charge, so surely the H plus will have an attraction towards the lone pair. So it will come and attack here, and this lone pair will donated, or it will move to the vacant orbitals of the hydrogen, and a bond is formed here. Okay, so whenever a lone pair is lost, we will represent that using a positive charge, and this particular ion is called anilinium ion. This particular structure is called anilinium ion. And some students will ask me a doubt, sir, anilinium ion can also show resonance, right, sir? Why? They are telling that positive charge, single bond, then you have double bond, single bond, double bond. So you have something that is called a conjugation is present. Then why, sir, anilinium ion is not forming a structure 2 that is mentioned here? You can see structure 2 that is given in the question is this one. Why it is not able to form this structure? I am telling here this is wrong. Why? The reason is very simple. If you see anilinium ion, you can see already the nitrogen, around nitrogen, if you see how many electrons are present, sir? 8 electrons are present. We know that nitrogen can accommodate, if you look at its configuration, nitrogen with atomic number 7, you can see 1s2, 2s2, okay, 2p3. So maximum it can accommodate maximum how much? Only these orbitals are present, sir. So it can maximum accommodate 8 electrons. Already 7, you can see 7 electrons are present, and maximum it can accommodate nitrogen. Its configuration is 2,5. So it can maximum another 3 more electrons and 8 electrons. So already here nitrogen has 8 electrons present here. Okay, now suppose it forms a resonating structure. How it forms resonating structure? Since positive charge is present here, the double bond will shift towards here. Then what will happen? It will form a double bond here, then a positive charge would come here. Okay, but the problem with this one is, if you see the number of electrons, 2, you can see here 4, then you can see here 6, you can see 8, then you have 10. Will it be possible? Is there enough orbitals present in the nitrogen atom to accommodate 10 electrons? Not possible. So that's why resonating structure would not be formed here. So the reason I can mention that the nitrogen atom does not have sufficient orbitals to accommodate the extra 2 electrons which is coming during the resonance. Okay, that is the reason. Okay, so I have mentioned here nitrogen atom has 10 electrons in this case, and which is not possible. Okay, now coming to the next concept. Okay, the statement 2 is totally a different statement, and it has nothing to do with the reason for the first phenomenon. The reason here is nitrogen does not have enough orbitals to accommodate the electrons. That is the reason for it is not forming a canonical structure like this. This is structure 1 and this is our structure 2. So this is not possible. Okay, now we should understand another concept that is called, whenever you have a positive charge present on a more electropositive atom would be more stable, and negative charge, if it is present on a more electronegative atom, would be more stable. What does this mean? Very simple, sir. Whenever I can explain this with a very simple example. I am taking sodium element. We know that sodium, it has atomic number 11. So its configuration is 2, 8, 1. So how it would become stable, sir? Very simple. It needs to lose 1 electron. So whenever it loses 1 electron, it would become Na+. Now I know that sodium is an electropositive element. So an electropositive element is always achieves stability by losing electrons. Then it will acquire positive charge. That is how we say positive charge present on a more electropositive atom is more stable. Now let's take another example, chlorine. We know that it has the configuration 2, 8, 7. So how it can achieve stability, sir? By completing the octet. So it will always have a tendency to accept electrons. Okay, it will always have a tendency to accept electrons. So I can say chlorine, on accepting electron, it will become 2, 8, 8. Okay, so it will become Cl minus. So I can say this is more stable. So I can say an electronegative atom or negative charge, if it is present on an electronegative atom, will make it more stable. Now let's try to understand. Now here I have given a tertiary carbocation. Now you can see a positive charge is present on a carbon atom. Carbon, I cannot say whether it's electropositive or negative, or it's almost intermediate stuff. So I can say it is somewhat stable. Why? But it is however stable through what phenomenon? Hyperconjugation and inductive effect. But whenever I am seeing ammonium, this is ammonia. So it has lone pair of electrons. So whenever it accepts the H plus, this will become ammonium ion. Ammonium ion. Now you see, after accepting H plus, the positive charge is coming on nitrogen, and we know that nitrogen is an electronegative atom because nitrogen has the configuration 2,5. So it has a tendency to accept electron and form 2,8. Okay. So nitrogen is an electronegative atom. So but it is getting a positive charge. So I can say this is an unstable compound. It will always have a tendency to remove the H plus. So I can say this is a good acid. Why it is a good acid? It can easily remove the H plus and it can easily form ammonia. Okay, it can easily form ammonia. I hope you understood. Now tell me, sir, go to the assertion and reason and analyze it. Okay, here I can say 1 and 2 are not acceptable canonical structures. So this assertion is a true statement. So it cannot form, this is not possible. Now second, they are mentioning the reason which is not at all related. The reason they are mentioning here is, what is that? Carbonium ions are less stable than ammonium ions. Carbonium ions are less stable. Is it like that? We have seen that carbonium ions present here are more stable than ammonium ions. Why? Because here positive charge is coming on carbon atom. Carbon is more electropositive compared to what? Nitrogen. Nitrogen is more electronegative. So here ammonium ion is formed means it is having positive charge, and this is a less stable compound. So I can say the reason statement itself is a false statement. So I can say statement 1 assertion is a true statement and the reason is a false statement. So tell me which is that correct answer then? Assertion is true but the reason is a false. Reason statement itself is false. Okay. So I can say my answer here is option 3 would be my correct answer. C means what? Assertion is a true statement but reason is a false statement. Hope you understood. Clear? Now let's try to check with the next question. So here they have given an assertion: aniline is a weaker base than benzyl amine. So they are given a statement like aniline is a weaker base compared to benzyl amine. We need to see what is a benzyl amine. Okay. Next they are mentioning the reason as in aniline mesomeric interaction. Mesomeric interaction is nothing but a resonance interaction. Or I can say another name of resonance effect is called mesomeric effect. Okay, in aniline, the mesomeric interaction occurs between the benzene ring and amino group. Okay, let's try to understand these two statements. Then we will make it clear. Okay. So as you know, aniline is nothing but benzene with lone pair connected to NH2 group. You can see this is my aniline, and once it is accepting the H plus, it will become anilinium ion. We know, and this anilinium ion has no resonance. We have seen that why it is like that in the previous question. Okay, now listen, they are telling aniline is a weaker base than benzylamine. So why I have done like this actually? Now please understand, a base has different definitions. Let's try that. What is a base fundamentally? Okay, so we have seen this concept of base in the chapter equilibrium. So what is fundamentally a base, sir? I can say base is somebody who H plus acceptor. H plus acceptor is a base. Base has a definition like that. Or we can say base is an OH minus donor. OH minus donor. Okay. And even I can say base as an electron pair donor. Electron pair donor. So if you see any of the definition in a particular compound, I can say that particular compound is a base. Okay. You can check this with any phenomenon, it's clear. Now similarly tell me, sir, what would be an acid in similar scenario? What would be an acid? How will you define an acid? Somebody is a good acid means he should be a good H plus donor. So that's why in our testing we will donate, we will remove the H plus and see the remaining structure is stable, because otherwise it will attract the H plus back. So if it is a stable guy, it will donate the H plus very fast. Okay, so H plus donor, or we can say this guy is an OH minus acceptor. Okay, or we can say this guy is electron pair acceptor. Electron pair, just opposite, you can remember like that, electron pair acceptor. So this is fundamentally the acid. Okay, now let's try to understand basic nature, because in this question we are talking about basicity. So in aniline, listen students, very simple sir, just focus on the reasons, then you will understand everything. Okay, so in aniline you can see lone pair is present, and because of this lone pair I can say H plus will come near to this and it can form bond, or you can say aniline is an H plus acceptor. Correct? But here one important thing, here it's a comparison. Here aniline is compared with whom sir? Aniline is compared with a compound that is called benzylamine. What is benzylamine? Very simple, this is called benzyl group. When benzene is connected to CH2, this particular structure is called benzyl. And since NH2 is connected to that, we say benzylamine. Suppose here OH is connected, then we say benzyl alcohol, like that. Okay, now we are comparing the basicity of aniline with the benzylamine. Listen, here also nitrogen has lone pair. So what it can do, the H plus can easily come and join here. So we can say this is also a base. Now comes the problem, sir, this also has lone pair, it can accept H plus. 1 minute. Okay, this can accept it. 1 minute, there is a hitch. Just a minute, some problems, we'll sort it out. Yeah, yep. It's very simple sir, you just need to focus about it, nothing, you don't need to worry, understand the comparison. So here both are H plus acceptors, so please understand the comparison. Both of them have lone pairs of electrons and they can accept it. Then how we will compare it sir? Please understand this NH2, this lone pair is not localized here. This aniline has resonance possible. Why? It's not, I am not talking about anilinium ion. Anilinium ion cannot show resonance, but aniline can show resonance. How? Why? Because the lone pair, you see, lone pair, single bond, double bond. So this lone pair will form a double bond here. Yes. Then positive charge would come here and a negative charge would come here. Here still you see nitrogen has 10 electrons only. Here double bond. So 2, here 4, and 2 hydrogen atoms means 4. So 4 plus 4, 8 electrons. No problem. So aniline is capable of forming resonance. But anilinium ion cannot show resonance. Please understand the difference. Okay. So what is the problem, sir? What is the problem if aniline shows resonance? Very simple. If aniline shows resonance, what will happen? This lone pair will move to the ring, and the availability of lone pair here disappears. There is no lone pair here in this particular structure. So that means it will keep on resonating, and the availability of the lone pair in the nitrogen is decreasing. So if it decreases, what happens? The problem is when H plus comes here, it cannot find the lone pair, then only it can accept the H plus. So I can say basicity or basic nature of aniline is very less compared to benzylamine. Why? Because even though in one structure it has lone pair, in the other structures the lone pair is delocalized, it is moving, so it has a less chance to accept the H plus. So I have mentioned here, above reaction shows the basic character of aniline. However, in aniline, the lone pair of electrons present in the nitrogen atom enters into resonance with the benzene ring. So hence the lone pair of electron is less available for donation or for accepting the H plus. But in benzylamine, we can see here lone pair, single bond, again single bond, so there is no conjugation. So I can say this lone pair here, it is localized. Localized means it will stay here. It is not delocalized. In the anilin's case, it is delocalized. It is moving. So I can say here H plus, you come at any time, sir, I can accept you. So I can say this is benzylamine is more what actually basic, or it has more basicity, I can say. Okay. Now you understood the reason why aniline is less basic compared to benzylamine. Now let's try to read the assertion again. Aniline is a weaker base than benzylamine. So I understood it's a true statement. You are correct. Aniline is a weaker base. Now, what is the reason they are stating? In aniline, mesomeric interaction, that is resonance, occurs between the benzene ring and amino group. Correct. Because of this resonance, only the lone pair is getting delocalized and the lone pair availability is becoming less. So I can say reason is a correct statement first, and this reason is a correct explanation for the assertion. So I can say assertion is a true statement, reason is also a true statement, because individually you take this statement, there is resonance between benzene ring and amino group, and this statement is an explanation for the first statement. So with that understanding, I say option 1 would be my correct answer. Why? In option 1, option A, we know that assertion and reason are individually true statement, and the reason is the correct explanation for the assertion. Hope you understood. Okay. Now let's go to something that is called the next question. So here again we have the acidic nature question is coming into picture, so we can apply our concept very easily. Okay, students, I know that you people are preparing very well for this year NEET. Please prepare it and please subscribe our channel. Surely you will get more important questions based on NCERT, completely based on NCERT, and this will surely help you to improve your NEET score actually. Please watch the channel. You will also get this as PDF, so you can save it, and maybe at the end of the time when you do the revision, you can do it. Okay, you can go through the questions. It will come for exams. All important questions I have tried to assemble here. Okay, let's try to see. So from Brainiacs Classes, this is Riyaz sir again. Okay, so here acidity of the following compound, acidity of the following compounds decreases in the order. They have given an order. So here you can see first one is an alkyne, then they have shown an alkene, then they have shown an alkane, and they are telling alkyne is more acidic than alkene, then alkene is more acidic than alkane. This is the first statement. Now if you look at the reason, they say that acidity of the compounds increase as the electronegativity of the carbon. Electronegativity of the carbon increases to which the hydrogen is attached. So we need to understand first statement in detail, then we will again go through the reason and see whether it is correct or not. Okay. Now let's try to understand, sir. So I am first taking an alkyne. Let's say terminal alkynes are acidic in nature. Let's try to understand. This is a direct statement from NCERT. Why? Terminal alkyne means what actually? First I will explain that. You have suppose an alkyne that is present like this, CH3, let me say CH3, C triple bond C, CH3. You can see this is also an alkane, but you can say here double bond is not coming on the terminal carbon. Triple bond is coming on the carbon that is present in between. So this type of is called non-terminal alkyne. So what is a terminal alkane? So we see whenever the edge carbon atom, whenever any of the edge carbon atom have triple bond is present, we say such compound is called terminal alkanes. And we say why terminal alkanes are acidic in nature? Very simple, sir. How will you check whether it is acidic in nature or not? I cannot find any electronegative atom here. So I am just removing the hydrogen from the carbon atom randomly. So I am getting the remaining structure. Now I need to see whether this remaining structure is stable or not. So we know there are three phenomena like resonance, inductive effect, or even hyperconjugation. Other than that, we need to check for one more phenomenon that is called electronegativity of the hybridization of the carbon. Electronegativity of the hybridization of carbon. Here, if I see here, this particular carbon atom has what hybridization, sir? If you see here, this have hybridization, that is sp. Here I can see this is sp hybridization. Okay, why it is sp hybridization? If you check it, this carbon, it has one pair of electrons here, and we know that pi bond will not participate in hybridization, and there is a single bond here. So there are totally 2 electron pairs. Whenever 2 electron pairs comes, S and P. Okay, whenever there are 3 electron pairs comes, what will happen? 1, 2, 3 electron pairs, then it would be sp2. Whenever there are 4 electron pairs like this, 1, 2, 3, 4, then it is sp3. Like that you can easily determine. Here if I am seeing it, this particular carbon, if I am seeing it, carbon has a negative charge, so 2 electron, and there is a sigma bond here, so 2 electron. Pi bond will not participate in hybridization, so S and P, and that is sp hybridization. Okay, so negatively charged carbon here is sp hybridized. And when I am taking the next compound, that is an alkene, terminal alkene, H plus is removed, I have the negative charge is present on what sort of carbons, sir? Here you can see sigma bond, and you can see here a triple bond is present here. Whenever double bond comes here, the hybridization here changes to, you can see how. Here also one sigma bond is connected to carbon, and one more hydrogen is there, yeah, and negative charge, so 2 electrons are present. So here totally how many electrons are present for hybridization? 6 electrons, or I can say S, here P. So totally this would be sp2. I can say here the carbon atom is sp2 hybridized. And when I am taking the last one, an alkyne, here also H plus is removed, so this will become CH2 minus like this. Now when I am checking the carbon, you have 2 hydrogen atoms like this and a negative charge. You can see here 2, 4, then 6, and then here 2, 8. So totally 8 electrons are present, so that is sp3. So I can say negative charge is present on sp3 hybridized. Now most important thing to understand is, whenever you have sp, sp2 and sp3 hybridization, I can say in sp hybridization, you can see one S and one P. So I can say 50% it has S character and 50% the hybridization has P character, or 50% S orbitals are present, 50% P orbitals, or we can say hybrid orbitals. In a hybrid orbital, 50% is S character and 50% is P character. Here in sp2, more amount of P character is present, or I can say 33.3% is only S character. How you are getting it? Only 1 is present out of 3. So 1 by 3 into 100. Here only 1 S is present out of total 4. So 1 by 4 into 100. So out of this, more S character is present in sp. So what is the importance of S character, sir? What happens if S character is high? We can say more the S character, more the stabilization of negative charge. Why? Because if S character is more, we know that S orbitals are near to the nucleus, and nucleus have positive charge. So if S character is more, that means the negative charge would be easily attracted more towards the nucleus, and that would become more stable. And that is the reason why I say in an alkyne, this would be the remaining structure after removing the H plus. That is, this structure is more stable. Why? Because this negative charge is near to the nucleus, or positive charge would attract the negative charge, or a negative charge would be attracted easily by the positive nucleus of the carbon atom very easily, and make this negative charge stable here. It will not attract the H plus back. Why? Because in more than this attraction, it would get attracted by the positive charge of the nucleus of the carbon. So please understand, whenever negative charge is connected to an sp hybridized carbon, it would be more stable. And this is the reason why terminal alkynes are more acidic. Why non-terminal alkynes are not acidic? Because there are no hydrogen. There is no hydrogen for the carbon to liberate. You can see here, no hydrogens are there. Okay, so the order is very much correct. We can say first alkynes are more acidic, then only alkenes, because here the S character is little more less, and here the S character is very less. So practical basis, we say this is only highly acidic in nature. These two are very less acidic. So now we can see the reason: acidity of the compounds increase, correct, as the electronegativity of the carbon increase. Correct. I told that here this carbon would be more electronegative. Why? Because it have sp hybridization. Whenever sp hybridization is there, it would be more electronegative. Why? Because it is more closer to the nucleus, and more electronegative means why it is attracted more towards the positive charge. Okay, so I can say here the reason is also correct. Reason is a true statement, and the reason is a correct explanation for the assertion. So I can say my answer here is option A is my correct answer. I hope you got a clear idea. Yep. Now we have the next question. This is very important. This is mentioned in NCERT, tropylium ion or tropylium ion. So the assertion mentioned here is tropylium ion is more stable than benzyl cation. And reason they are mentioning is tropylium ion is anti-aromatic in nature. Let's try to understand this. So what is tropylium ion? So let's try to understand the structure of a tropylium ion. This is the tropylium ion or a tropylium cation. Please understand it has the benzene has a six side, but the tropylium you can see 3, 4, 5, 6, 7 sides are there. So 7 side structure is called tropylium cation, and here you can see positive charge is present on a carbon atom. Then you have alternate single and double bonds are present. Such a structure is called tropylium cation. Okay, now if you see this particular structure, I can say first thing here is this is aromatic. Why it is aromatic, sir? What are the 4 conditions you check for a compound to be aromatic? First thing is it should be cyclic in nature. Cyclic means it should be a ring actually. So you can see it is a ring. Next thing is it is planar. Planar means every carbon atom should present here is sp2 hybridized. Here I am checking this particular carbon atom, you can see the number of electrons 2, 4, and there is a hydrogen atom present here that is not shown. So another 2 electrons. So 6 electrons comes means it is sp2 hybridized. Here also you can see 1, 2, here the third one, and the fourth one is a hydrogen atom. So how many sigma bonds are there? 1, 2, 3. So that means 6 electrons are present. So this is also sp2 hybridized. So see, these carbon atoms are similar to what I have explained just now. So I can say the entire structure is sp2 hybridized. So what is the importance of sp2 hybridization? sp2 hybridization means it is planar trigonal or it is planar in nature. So that is the second condition is satisfied. Now the third one is cyclic resonance. Cyclic resonance means conjugation, continuous conjugation is called cyclic resonance. Positive, then single bond, double bond, again single bond, then double bond, again single bond, double bond, then again single bond, then positive charge, again single bond. So it is like continuous resonance. Cyclic, there is no break. That is called cyclic resonance. That is also present. Next one is it is obeying 4n plus 2 pi electron rule. What does that mean? 4n plus 2 pi electron rule means you need to put various values for this 4n value. If I am putting n is equal to 0, it would become 2 pi electron. When I am putting n is equal to 1, this would become 6 pi electron. If I am putting 2, it would become 10 pi electron. Now what we need to check? Check here how many pi electrons are undergoing delocalization. I can see here totally 6 pi electrons are there, and I know that 6 is a value. 6 is a value that will come to this particular formula when n is equal to when n is equal to how much, sir? Okay, so when n is equal to 1, we would easily get 6 pi electron. So please remember, how will you check this particular rule? Put n is equal to various values and you would get this as 2 pi electron, 6 pi electron, 10 pi electron, and you count the number of pi electrons present here. And if you found any number that is coming here, then it is following 4n plus 2 pi electron rule. Suppose if you are counting this and you find 4 pi electrons are there, but I could not find 4 here, 4 is not present, then it is not. But when I am counting here, I can see here 6 pi electrons are there. So 6 pi electrons is a number that is coming when n is equal to 1. When n is 1, this is getting 6. So I can say it is following 4n plus 2 pi electron rule. So these are the reasons why I am saying tropylium cation is aromatic. Okay. Then next thing is whether it has cyclic resonance. So let's see how much this is stable. So we can see its resonating structure here. So first structure, propylenium cation is there. So how to draw the next resonating structure? Positive charge, single bond, double bond. So pi bond will move towards here, the positive charge, then it forms a double bond here, then positive charge would come here. Next structure, double bond will come here, then the positive charge would come here. You got the next structure. Then again the double bond would come here, then here double bond will come and positive charge would come here. Again double bond would come here, then the positive charge would come here. Please understand, all these structures are different only. You can see whenever the number of corners, please, this is a shortcut trick I am telling. So whenever the number of corners are odd in nature, whenever it is odd, here 7 corners are there, then while doing the shifting, the positive charge would come at all the structures, all the corners. So I can easily say whenever number of corners are odd, the number of resonating structures would be equal to the odd number. So here 7 corners are there, so usually there are 7 resonating structures would be there. Correct? But you can compare this with the next one. They are comparing this with the benzyl cation. So when I am taking the benzyl cation, you can see here in the ring how many corners are present. You can see here 1, 2, 3, 4, 5, 6 corners are there. And you can easily see the positive charge is not coming at every corners. You can see when I am drawing the resonating structures, how many are there? 1, 2, 3, 4, 5 are only there. So I can say more number of resonating structures are present for propylenium cation, so that would be more stable. Here how will you draw the resonating structure? Positive charge, single bond, double bond. So double bond will shift it to here. So positive charge comes here. Again positive charge, single bond, double bond. So double bond would shift it to here. Then positive charge would come here. Again double bond, single bond, positive charge. So double bond would shift it to here. Positive charge will come here. Then double bond would shift it to here. Then positive charge. Then again you got the same structure. Next structure would be what? Again double bond would come here. Positive charge would come here. That is nothing but this structure only. You are getting again the same structure. So 5 resonating structures are only present. Okay, 5. So let's analyze the statement. Now we can say propylenium ion is more stable than benzyl cation. Why? Because propylenium ion has more number of resonating structures. And we can see reason, propylenium ion is anti-aromatic. Of course not. We have seen it is aromatic in nature. So this statement itself is a false statement. So we can say first is a true statement and next is a false statement. So we can say assertion is a true statement but reason is false statement. So that is option. Tell me, sir, option C would be my correct answer. Okay. So I hope you got a fair idea regarding this question. Okay. Try to draw the resonating structures and try to enjoy it. Or you can even take a screenshot. Most of the books doesn't show the entire resonating structures. Okay. Yep. So I hope we have discussed enough questions. We have more questions coming for you. You can see more assertion and reasoning questions with very good explanations we are giving it. So you can subscribe our channel. Okay, you would get more explanations, and the revision questions are, you can see 100 more pages, more number of, you can see revision questions. It's like never ending with more important questions coming on your way. Okay, so please come to us. Next week also we will continue it. Try to increase the frequency of the videos. So please subscribe our channel, very important. Then please press the bell icon to get the notifications. And if you have any doubt, please put it on the comment box, and please feel free to contact on the below number if you need any assistance in the offline form. Okay, so thank you. Signing off. This is Riyaz sir from Brainiacs Classes. Bye.